In this lecture, we're going to show advanced mate width. So we have this assembly from the previous lecture, and we have this part 3 that we can move here and that we can rotate. And now, for example, we want to position this part right here in the center of the assembly, in the center of this cylinder, like we did in the previous lecture. But this time, we're going to use tool width. To show how this works, let's go here to Assembly tab. Let's choose a mate. So here we have standard mates. We won't use standard mates now. We're gonna go here to advanced mates. So let's open this and let's choose this one, width. Here we have two dialog boxes. The first one we have a width selections, and then we have a tab selections. Here we have to choose between which two faces we want to move this part 3, or between which two faces we want to center this part. So we can choose those faces, this face and this face here. We can also choose this face here as well on the other side, or we can choose this face here. So for example, let's choose this face and this face here. And now we have to choose two faces of this part. So let's choose this face here and this face here. And now we can see that automatically part 3 goes right in the center. So let's click OK. And now if we try to move this part, we can't move, we can only rotate. So this part is right in the center. So this is the second option how you can center your part. Now let's go to mates here. Let's go here to the width 2. Right click, and let's go edit feature. And now let's go down here. So here we have constraint. By default we have centered, which means that this part goes right in the center between this face and this face here. But we can also change this. Let's click here. Here we have a free. Let's choose free. And let's click OK. And now let's try to move this part. Now we can see that we can move this part between those two faces here. This one and this one here. We can go behind this face and we can't go behind this face here. Only between them. So we can move part only between those two faces. Now let's go to mates. Let's go right click here and let's go edit feature. Let's go here under constraint and now let's choose dimension. So what that means that our part will position 89 millimeters, 89.57 millimeters from this face here. We can go here, we can put for example 50 millimeters, and now distance between this face here and this face here is 50 millimeters. We can also go here, flip dimension like this. And now here we have 50 millimeters from this face to this face here. Now if we click OK, now if we try to move this part, we can't. We can only rotate this part like this. Now let's go to width again, right click, edit feature. And now here we have a percent, which is the same as distance, but instead of using millimeters, we're using percent. So here we can go, for example, 30%. And now our part is positioned on the 30% of the distance between those two faces. This one here and this one here. We can also go here, uncheck flip dimension, and now we have 30% from this side, like this. So you can use percentage, or you can use, for example, distance. If you put here 50%, now our part is right in the middle, like this. Let's click OK. And this is what we want to accomplish. So this is how you can use a width tool. In this lecture, we're going to show advanced mate tools, distance and angle. We already showed the standard mate tools, distance and angle, but now we're going to show advanced. With advanced distance and angle, we can define the range of the distance and range of the angle. So here we have this cylinder. Now let's go here to the section view, like this. And let's click OK. And here we have this cylinder, so we can move this part from this face here to this face here, as you see. Like this and this. And now, for example, we want to position this part 50 millimeters from this face. So we can just go here to Assembly, Mate. For that, we can use also Standard Mate, but let's go here to the Advanced Mates. And here we have distance. Let's check this. So here we have two options. We can define the exact position. For example, let's go 50 millimeters between this face and this face here. And now here we have 50 millimeters. Let's click OK. Now if you try to move this, you can't, because it's fixed here. Now let's go here to the mates again. Let's go to distance, right click, edit feature. Let's go here down, let's go to advanced mates. And here we have two options. We have maximum value and we have minimum value. So for example, for a minimum value, we can put 10 millimeters. For a maximum value, we can type in 110 millimeters, like this. And now let's click OK. And now if you try to move this part, you can see that this part goes 10 millimeters from this face. This is the starting position, and goes here to the 110 millimeters off from this face to this face. So this is how you can define the distance range using distance advanced mate. You can define a range in which your part will be movable. The same thing you can do with angle. So let's open a new assembly. So we have this assembly here, and this part we can rotate around this cylinder here. And now for example, we want to define an angle between this face and this face here. We can go to assembly, mate. Let's go to advanced mates, and here let's go to angle. So we can define here, for example, 60 degrees between this face and between this face here, like this. Let's click OK. And now if you try to move this, you can't move. You have 60 degrees between those two faces. But also we can define the angle range. For example, we want that this part will be movable between 10 degrees and 150 degrees. So let's go to angle here again, right click, edit feature. Let's go down, let's go to advanced mates. And here we have angle range. We can go with maximum value. Let's go 150 degrees. And for the minimum value, let's go 10 degrees, like this. And let's click OK. And now if you try to move this, you can see that you can go from 10 degrees to 150 degrees to here, like this. And now we can see that here we have limit angle 1. Let's go right click, let's go edit feature. Let's go down, and here also you can go with flip dimension. So you can go to the other side as well. You can change alignment, like this. Now let's click OK. And now we have this one, from 10 to 150 degrees. So this is how you can define the distance and angle range in assembly creation. In this lecture, we're going to show the advanced mate profile center. So we have this part here, this one, and here we have a plate of this table. And now we want to put this plate right in the center of this plate here. So we want that this cylinder will go to this hole here. We can do this using standard mates, coincident and concentric. So we could make concentric relation between this cylinder and this hole, and then we could make coincident relation between this face and this face here. Or we could make coincident relation between this edge here and this edge here. This one. That would also work. And this is how you can do this by using standard mates. But you can also do this by using advanced mate profile center. So let's go to assembly tab. Let's go to mate. Let's go to advanced mates. And here we have profile center. So let's choose this one. Now we have to choose entities that we want to mate. Now we want to put this face right in the center of this face, like this. And now let's click OK. And this is what we want. If you try to move this plate, it's not possible. We can only rotate this one. But if you don't want a rotation, we can go to mates, right click, edit feature. And here we have lock rotation. So let's check this one. And now let's click OK. Now if you try to rotate, it's not possible because we locked rotation. So this is the simplest way how you can do this by using profile center. Now let's go to another example. Now we have this table, so we don't have now the circular plate. We have this plate now. And now we want to put this plate right in the center of this rectangle here. For that we can also use profile center. So let's go to assembly tab, Let's go to Mate. Let's go to Advanced Mate, and let's go to Profile Center. Now let's choose entities that we want to mate. We want to mate this face here and this face here, like this. And let's click OK. Now we got this result. Now if you try to move this, it's not possible. If you want to rotate this, we have to go to Mates, right click, Edit Feature, and here we have Possibility Orientation. So we can go here to clockwise or counterclockwise. So if you click this, now can you rotate this plate? Like this. You can go to other direction, like this. As well, here we have an option offset distance. Now we have a 0, so between those two faces the offset is 0. You can define the offset here, for example 5 millimeters, like this, but we want to go to other direction. Let's go here, flip dimension, like this, and let's click OK. And now here, between those two faces, as you see, we have a gap of 5 millimeters. If you try to move this table, it's not possible. So those are all possibilities that you can do with the Profile Center. In this lecture, we're going to look at Advanced Mate Symmetric. So for example, here we have those two parts, this one and this one here. And now we want to define an angle between this face on this part and this face on this part, between those two faces and the right plane. And we want that those angles will be the same. So what that means, when we're going to move this part here, this part will automatically move also to this position. Or if we move this part will automatically adjust its angle to this right plane here. For that we need a mate symmetric. So let's go to Assembly tab, let's go to Mate. Let's go to Advanced Mates. Let's choose here Symmetric. So first we want to choose Symmetry Plane. So let's go here, let's choose the right plane of the assembly. And here we have to choose the faces, entities that we want to mate. So let's right click, let's delete this edge, and let's choose this face and this face. We can also choose this face here and this face here, it's the same thing. And now let's click OK. And now if you try to move this part, we can see that the second instance of the part 3 is simultaneously changing its angle relative to the right plane. Like this. Or if we move this part here. Like this. So this is how it works Advanced Mate Symmetric. In this lecture, we're going to show Advanced Tool Linear Coupler. So let's look at this assembly here. Let's go to other side, here, to the bottom. Here we have two cylinders, this one and this one. So let's try to drag this one out. So we see that these go first out, and then the second one follows him, like this. And now, for example, we want to make that those two cylinders will go simultaneously out. So if one goes out 10 millimeters, the second goes out also 10 millimeters. So let's go to the first position, initial, this one. And for this we need linear coupler. So let's go to Assembly tab, let's go to Mate. Let's go here to Advanced Mates, and here we have linear coupler. So let's choose this one. Here we have to choose entities that we want to mate. So in this step, we're going to choose this first cylinder. And then here, entity to mate, we're going to choose the face of the second cylinder. And here are some reference that we can choose, but we won't use that in this lecture. Now let's go down here. Here we have a ratio, 1 to 1. 1 millimeter to 1 millimeter, which means if one cylinder goes out 1 millimeter, the second one goes out also 1 millimeter. So let's click OK. And now let's try to move this cylinder out. And now we can see that those two cylinders go out simultaneously for the same amount of the length. Like this. And now, for example, we want to make that this cylinder will go out for 2 millimeters, while these cylinders for those 2 millimeters will go out 1 millimeter, this one. To accomplish that, we can also use linear coupler. So let's go here. Let's go Edit Feature. And let's define here 1 to 2 ratio. Let's put here 2, like this, and let's click OK. Now let's drag out this cylinder, and now here we can see that we have a ratio 1:2, which means that for each 2 millimeters that these cylinders go out, this one goes out 1 millimeter. Let's go to initial position. Now let's go to linear coupler, edit feature, and let's put here 4, for example. Let's click OK. Now let's drag this out, and now we can see that for 4 millimeters of this cylinder goes out 1 millimeter. And this is how you can define the relation between 2 cylinders by defining the ratio. In this lecture, we're going to show how to use Advanced Mate Pad Mate. With Pad Mate, we can achieve that this ring here will follow this pad here, like this. So for that, we have to go to Advanced Mates. So let's go to Mate. Let's go to Advanced Mates. And let's choose here Pad Mate. We have 2 dialog boxes here. In the first one, we have to select some vertex or a point, and in the second one, we have to select a pad that this point or vertex will follow. So for example, we want that this ring will follow this pad here, and we wanted that center point of this ring will follow this pad. So we have to choose here the center point. So let's go to Assembly. Let's open Part 2, Boss Extrude 2, and let's show this sketch here. Right click and show. And here we have a point, center point. Let's choose this. And now we have to choose a pad. So now we have to show our pad here. So let's go to Assembly. Let's go to Part 1. Let's go to Sweep. And let's show this 3D sketch. Show. And let's choose this 3D sketch. Like this. And now we can click OK. Now let's click on this 3D sketch again and let's hide it. Let's click on this sketch here and let's hide it like this. And now we can try to move this ring along this pad like this. And this is what we want to achieve. But one thing, if you notice, this ring follows this pad, but it rotates along the center point. But for example, we want to constrain that rotation. For that, we have to go to Mate here, and we have to go to Pad Mate again. Edit feature. Let's go down, and here we have few options. We have a pad constraint, we have a pitch control, and we have a roll control. So first we're gonna show pad constraint. Now we have a free. Let's click here. So here we have 2 options more: distance along pad and % along pad. Let's first go with distance. So first we have to choose here the distance from the end. We can choose here, for example, 40 millimeters. And now our ring is 40 millimeters from this point. Let's click OK. Try to move your ring. It's not possible. You can only rotate this. Let's go to Pad Mate again. Let's exit here. Edit feature. Here we have option flip dimension, so we can go to other side. And now our ring is 40 millimeters from this point here. So with pad constraint, you can constrain the movement of the part along the pad. As well, instead of distance, we can use % here. So we can put, for example, 50%. And now our ring is on the 50% of this pad. So this is how you can use pad constraint. Let's go with free. Like this. And now let's show pitch control. With pitch control, you can work on the orientation of the ring. For example, now we have a free. So as you saw, we can rotate our ring around center point. So we can choose here, follow pad. Let's choose this one. And now here we have 3 axes, X, Y, and Z. And now, for example, if we choose X axis, that means that this ring is orientated toward X axis. If we go to Y axis, now our ring is orientated toward Y axis. And those axes, X, Y, and Z, are in the relation to the pad. They're not in the relation to the origin of the assembly. So now let's click OK. And now let's try to move our ring. And now our ring is always perpendicular to the pad. And now it looks more finer. Let's go to Path Mate again. Edit feature. And let's go here with free. Now let's look at the roll control. With the roll control, we can also work on the orientation of the part. So let's choose here, instead of free, up vector. And now here we have to choose some linear edge or planar face. So we're going to choose this edge. And now our ring is orientated relative to this edge. As well, we can choose here X, Y, or Z, like this. Let's click OK. Let's try to move now, like this. And now we can see that the ring can rotate around Z axis. And this is how you can use Advanced Path Mate.